When we are dealing with some raw data, numbers, like 3, 5, and so, or floating numbers, doubles, and so on, or even strings, we know how to compare them. Like 5 is greater than 3, yes, it's obvious. Or in an alphabet, B comes after A, so we know it. But how can I compare two objects, like two students? How can you compare them? So for each scenario, that might be different. Maybe I want to compare them based on their names, like I want to sort them based on their names. Maybe I want to find the highest achieving students. I want to sort them, compare them based on their GPA scores. And you might apply it for all, like how can you compare two rectangles to, I don't know, this chair object and then another chair object? How would you like to compare them? So there is no one right answer for that. Like I know how to compare 3 and 5, but I don't know how to compare chair and a desk. So we might get into these kind of questions when we are dealing with objects. So that's why we also need to define CompareTo methods. Why do we need it? Well, again, maybe we want to sort them in some order. So we have to define what is our criteria to compare these two objects. That's why it's common also to define CompareTo objects. Like let's say that we have a student class and then we want to compare student with another student. So that's why it takes another student object as a parameter. Then the inside of this method might change in all different scenarios. Like in this scenario, we want to compare them based on their ID, and apparently it is like a numerical value. So, and then we want to say, okay, ID of this class is, if it is greater than the other ID of it, I will return 1. Otherwise, I will return 0. If they are same, I will return 0. So this is this kind of a coding. Like, why is it 1? Why is it -1? Or why is it 0? Well, of course, it depends on how you want to implement. But in most of the cases, like this is like a tradition. When we are comparing that, we use these specific numbers. If they are same, it is 0. If it is not, -1, and so on. This is most like a tradition. But I want to use these numbers to sort it. Of course, there is also another aspect of it, which is about interface functions that we will see in the following chapters. But then it will make more sense. There's a common comparable interface that provides this CompareTo functions, but we didn't come to that point yet. So for now, I will not get into more detail. But basically, when we define this kind of a CompareTo function, so I can use one student object and compare with then another one, and then get the result, and then I can use that result with my encoding. Like if it is 1, okay, this is greater. If it is -1, then S2 is greater. If they are same, then the result should be 0. But again, at the end of the day, the main thing is that, yeah, we have to also define how to compare two objects. It might be different for each scenario. All right. Do you have any question?
What does it compare? The IDs, what does it compare? The sum, the ASCII value, or like?
Oh, that's a good question. Well, of course, we don't see the other types of this class. But since we are using this greater than equal to signs, it seems that those IDs are some either float, double, or integer, probably integer or long. So it shouldn't be a string. But of course, again, it depends. If we had defined ID as a string, then yeah, we should also change its content. But again, the content might change for all. Like maybe it can be based on ID, based on name, based on GPA, based on college, whatever the criteria that we need. But the main idea is that, yeah, we need to define some CompareTo functions that will allow us to compare it with other students, with other objects. All right. Just as a reminder from our last discussion, from the last lecture, I have this code, but this is not a very good code actually. This needs to be improved. Do you have an idea how this CompareTo function might be improved? Should be improved?
I mean,
handles the null.
Null, yes. So the thing is, I'm doing this. Okay, ID is this class, and then it is greater than other.id. When I'm doing this comparison, there is a possibility that some function s2 this way might be null. Maybe it's not initialized yet. Then, if this is null, I would say null.id, it would crash my program. So it would be better, or it is also necessary to say that, okay, if other is null, then, I mean, how would you compare it? Maybe you would just say, okay, if it is null, return 1 immediately, and don't go to other cases. If it is not null, then you can do the other steps. All right. Now, this is end of chapter unit 2. Now we will go with the unit 3, arrays and array lists. All right. Yeah. So what is arrays and array lists? So from Python you already know it, but so we will. No, yeah. So the quiz will cover everything we have covered until last week. So whatever we see this week will not be covered in the quiz, okay? But yeah, it will be in the midterm. So you know the arrays, so I will be probably a little bit more quick on that. But array list might take more time on this. But before coming to that, I want to look at this slide. I think this is also important for the quiz, by the way, this slide. Because it summarizes what you have seen so far. And I want you to get, like once we finish this unit 2, this is like your checklist. Are you able to do these things? Like define a class, create an instance of it, and then do you know what are the variables, instance, local, static, and this. And for the methods, constructors, static methods, public, setter, gathers, method overloading, and those access modifiers. This is like your checklist, okay? If you are also studying for the quiz too, just please be sure that you covered all these topics, okay? So this is also important note for us. All right. Now let's begin. So what is the basic concepts of array? Well, again, this is kind of a different from the Python. In a list, I can put integer and some string in it, and then some boolean value, right? The data might be different. Like I define a list, and then the first item might be string, the other one can be an integer, the other can be boolean, the other one can be again a string, and so on. So the data type can be changed. But in Java, it is not the case. So the basic idea is to put the same data type in one place. Like all of them should be integer, or all of them should be a float, all of them should be student object, all of them should be boolean, and so on. So this is one big difference. And arrays are objects actually, so they're not raw data types, which means that also we can only create them with the new keyword. So like we say student s is equal to new student, like we create a new student object. We do the same thing for the arrays with the new keyword. And then arrays, well, keeps the data in contiguous order in the same block. So this is, I want to keep this information. Like, what does this mean? Let me illustrate it with our class, okay? So let's say that each chair is 1 byte in our memory, okay? And this is our memory location. So we keep the student objects in each 1 byte. Of course, student object should be more than 1 byte, but anyhow. So we write the data, like, and each of them has an address, like address 0, 1, 2, 3, 4, 5, 6, and it moves on. And when I say array of size 4, I mean that it will be continuous, like from starting from 0 up to 4, this part will be allocated to my array. So it will not be like this. I have 4 elements in an array, and one of them is here, the other one is here, the other one over there, and the other one over there. This is not the case in array. Why is it important?
For set list maybe, or set arrays that you don't want to add extras for it to be set hard coding.
It is. I'm planning to do an experiment on this. It is very good from a performance issue. Like I keep the data in one place, so it makes me much easier to access the data. There's some technical advantage of it. So, but this, and when we come to the array list, I will elaborate on this. But this contiguous means that yeah, they sit next to each other. The good thing is that, so if I know that my array starts here and it has a size of 1 million, I can immediately know where the last item is in my memory. I can just calculate it. Like I just need to move to 1 million address location, then it should be there. So this is the main idea. But arrays also has a fixed size. So what it means is, when I first create an array with a new keyword, I should say, okay, I need an array of 5 elements. Okay, then that's it. Then when I'm running the execution, then I realize, okay, I made a mistake. It should be 6. Now I will just add one more. We are not allowed to do that. Like if we, so we have to. Once we said okay, it is 5, then it is 5. The reason is that like you might think also it comes because of this contiguous allocation of the items. When I create that, okay, it is 5, so the computer allocates 5 memory locations for that, and then we continue the execution, and maybe the computer will fill those other parts. Then you don't have the permission that, okay, I made a mistake. It shouldn't be 5, it should be 6. Then it will not be allowed because maybe that part is already filled with some other data. So when we are saying, okay, we are creating an array, we really need to be sure that it's data size. So that, well, of course, it cannot be resized. We can only resize it with a very costly process, which is I need to, like I have an array of 5, and then now I need 6. And what I should do is I should create another array of 6. I need to copy all those 5s to there, and then I can put the 6. So it is pretty costly part to resize it, to create another array and change its size. And yeah, we can keep objects like student objects, so we can have student arrays, or we can have primitive data, like we can have integer array, double array, float array, or Boolean array. Now let's look at some examples for it. So how do we define it? Int, so it's a primitive data, and then we put these square brackets to define the data type. So whenever we see these square brackets opened and closed immediately, it means that this is an array of that type. So this is an integer array, and then this is its name, and then we use this new. So because it's an object, so we create we allocate some memory in the heap and then it's type again int, so it should be matched with those. And then between those square brackets, I define the size of it. Like I need a data size of 12 that can keep 12 integers. So this is an important part. This is one way, or I can first only declare it. Okay, C will be an integer array, and then I can create the array in another line. That's also possible. I can declare multiple arrays in one line, like A, B, C, and all of them are an integer array. And I can declare one integer array or any array, then I can declare the other variables. So when you see this statement, it means that, okay, int A, now square brackets are ahead of the A variable, as you can see. It means that A will be an integer array, but B and C, they will be just integer. That's it. So, and the value of C is 3. So I declared A, I declared B, B is an integer, A is an integer array, And C, I declared it, and I also initialized it to 3. And also, as a last part of how to declare and initialize an array is this with these curly brackets. In this one, what is happening is I declare an integer array n, and it has 5 elements, and I also fill it. Like the first item will be 10, then 20, 30, 40, and 50. In the other ones, when I say that, okay, C is equal to new integer 12, it's an empty array. I just allocated the memory, but I didn't fill it yet. But in this one, I allocate the memory for 5 integers, and I also fill them like 10, 20, 30, 40, and 50. So this is, in one line, I can also initialize and put the values that I want to put. But in this one, it is just an empty array. The memory is, the location is allocated, but it is empty yet. Shall I proceed? So, again, when I say integer array num is equal to new integer with a size of 3, what happens is, yeah, we created this consecutive memory relocations for that array. And then so we have these 3 things, like in Python, we have how to access it, like an index starts from 0, so first item, second item, third item, and the value. Here I didn't put any any value yet, I just created it. So then what will happen is, it will put the default values for each data type. If it is integer or double or so, it will the default value is 0. If it is an object, like student array, string array, or rectangle array, then it should be it's in the do not disturb mode, but still it rang. I don't know. Anyway, it will be null, and if it is a Boolean array, then the default value will be false. And I already mentioned that, like we keep only the same data type, like integer array, or double array, or a char array, and each of them we should define the data size, 110 or 26. And yeah, we also mentioned those things. And when we do this, like we initialize an array, what happens is, again, I say the numbers and then 1, 2, 3, 5. So we allocate the space, and then we don't, instead of putting the default values, which is 0, we put those values, which is 1, 2, 3, 4, 5. So that we don't put the default value, but we put the value that we would like to have. And again, the index starts with 0, as in Python. So this is also same with Python. And when I want to access any of those items, same as Python, I can say I need to use these square brackets, and I need to put this index number. But different than the Python, I cannot put -1 or so. So what would happen in Python if I say numbers between bracket and the index is -1? What will it return in Python? The last one, which is at this part, it will be 4, so it will return this value. But in Java, you'll get an error. The program will crash. So you cannot the index should be always between 0 and the number of items -1. So if we said that its size should be 5, then the index should be between 0 and 4. Shall I proceed? Okay, I think everyone is almost here. So let's take 1 minute break and take the attendance, and then continue.